Hey, what's up guys? Real nice to see you again. Welcome to a new Amaze. So in today's video, we are going to learn about how to run load tests on your ML applications. In particular, we are going to use a framework called Locust for that. I think this is a really cool framework. You program all the load tests using Python, and it provides a really well monitoring dashboard to check all the results of your tests. So yeah, this is the framework that we are going to use. But before we get into the code that I have prepared for you, I just wanted to give you an intuition of why these load tests are necessary for any ML application or any software application, to be honest, when you deploy them into production. So suppose or picture the following scenario. You have built a really cool ML application. Take, for example, a music recommender system. And you have developed a very responsive backend using FastAPI, for example, and a really smooth and well-performant frontend using Streamlit or Gradio, whatever you want. Now, the thing is that you have been testing the application with a few users. But as time goes by and your application starts getting attention, there is a rapid increase in the number of users using your application, and that's a problem. That's a problem because as time goes by, you start receiving complaints about your app being really slow, or even worse, not working at all for some users. Now, what went wrong? So probably your server handled really well a few users when you were running your tests before deploying it into production, but it's struggling to keep up with this rapid increase in users, to these sudden spikes of users. And that's something that, of course, you should have tested before launching your application to the public. And that's exactly what we are going to check today. We are going to use the framework, as I said before, a framework called Locust for all of this, for testing, for running these load tests against our ML applications before we deploy them into production. Of course, I'm not going to deploy anything into a productive environment today because it defeats the purpose of this tutorial. I'm going to do everything locally, but as you can imagine, you can simply readapt this code to your specific use case. I mean, it's really easy to adapt. So the first thing that you need to do to follow this tutorial is to go to the Neural Maze organization, and inside just go to the repositories tab, and you will have to look for Locust if you want, but it's basically the first repository that you will see. It's called Locust example, and if you run inside, you will see a very detailed README file with all the information about how to set up the project, deploy the FastAPI example in Docker, running Locust, etc. So we are going to follow this README, and I will clarify and I will add some explanations when I consider it to be relevant. Okay, so yeah, first thing that we need to do, set up the project by cloning the repository. So I have cloned the repository before. It's right here in my VS Code. So yeah, you have to do basically the same. After that, we are just going to install the requirements. Let me show you the requirements here. It's basically FastAPI for the backend that we are going to implement. Transformers, because the API that I'm going to build is basically a sentiment analysis application. You pass a piece of text, and the API is going to return the sentiment of that text. Then we are going to use Redis for the cache layer, FastAPI cache for adding the cache decorators to our routes, Pydantic for defining all the schemas, and this is the main topic of the video, Locust for all the load testing. And finally, Torch, because we need Torch for using transformers, for using the pipeline in transformers, as you will see. All right, so yeah, the first thing that we need to do then is to install the requirements. Pip install our requirements, and that's it. I have installed everything before, so it will be really fast. In your case, probably it won't. All right, so now we are going to start the FastAPI application, okay? And I will show you how to do it in a couple of minutes because it's just a Docker compose command. But before, I want you to understand what is happening under the hood, although I'm not going to put a lot of detail into this because it's not the main purpose of the video. But yeah, it's cool for you to know how this is implemented. So inside the API folder, you'll see two modules, the main.py and the schemas.py. The schemas.py contain the two schemas that I'm going to use. So it contains one first model, which is the text input model, that contains just one field, which is the text. This is the text that we are going to pass to the application, to the FastAPI backend. And then we have the sentiment output, which is the output of the root that we are going to use. That contains two fields, the label field and the score field, as we will see, okay? So yeah, and then in the main.py, it's where I'm defining the core logic of the backend. So I'm importing regular FastAPI, HTTP exception, schema, importing the schemas, also the FastAPI cache. I'm not going to get into these details. The only thing that might seem relevant for you is that I'm importing this transformers pipeline. Okay, and that's necessary to import the distillBERT model that I'm going to use for classifying the sentiment of the text. All right. Yeah, I'm generating this LRU cache for importing just one time. This is basically generating a singleton pattern under the hood, and we are returning the Hugging Face pipeline. Then you can see the startup function that contains all the setup of the Redis database for the cache layer. And we pass this method, this function, to the lifespan attribute of FastAPI. This means that when the FastAPI application starts, it will initialize the FastAPI cache, okay? In this case, the Redis backend cache. Then we are going to define the root. This is example API. This is the message that's going to return when we access the root. And then you will see the main endpoint of this application, the predict sentiment endpoint. And what it does is to get the Hugging Face pipeline that we defined before, and after that get the sentiment analysis of the text that we are passing, okay, as input to this endpoint. And after that, we are returning the model that we defined in the schemas.py. Okay, so this is basically everything that's going to happen in this application. As you can see, it's really simple, and I mean, it's not the main focus of this video. All right, so to start this FastAPI application, we are going to copy this Docker composed command. We are going to run it in here. In my case, it's going to be very fast because the images are already created. Maybe in your case, it will take a bit longer, but the FastAPI application is going to be running on this root right here. So now we are going to open FastAPI application. Let me see what is happening. Okay, let's get into the doc. All right, so here we have it, the FastAPI application with the root and the predict sentiment. And now if we want to see that everything works as expected, let me copy and paste some of the examples I have in the repo for the load test. So for example, this one, and let's see the sentiment that the application provides. So the text says, I absolutely love this place, the ambience is amazing and the food is delicious. So this is a very positive comment. So if we send this text to the application, we should expect a very positive sentiment. So let's execute this and let's see the results. So the response body is a label positive as we expected, and the score is really high. And that's normal because the distillBERT model has checked a lot of words that really signify a very positive sentiment. So we have the FastAPI application working right now. And now we are going to run Locust. But before we get into the Locust dashboard that I think you're going to enjoy, I want to show you the Locust file. So when you want to use Locust, when you want to use this framework to run the load test for your ML applications, you will need to create a file like this, locustfile.py. And inside you're going to define the load tests that you're going to run against your application. So the few things that you need to import from Locust are the HTTP user, the task, and constant pacing. Let's see them in detail in the code. So yeah, by the way, the first thing that we are going to do is to simply load the JSON file, this JSON file right here, where I took the example that we used previously. These are the examples that I'm going to send to the application in the load test, okay? But yeah, this is basically it. We are going to load the JSON file and allocate the result into this, this constant, the comments constant. And then this is basically the class that Locust is going to use to run the different load tests. You can see that it inherits from the HTTP user that we defined previously. And we are going to define one single task. Of course, you could define any task you want inside. For example, we could generate another task for the root method, like get root method. And in here, we will put something like, hey, self.client.get and just get here. And yeah, we'll have another task. As you can see, it's really easy to define different tasks, or we could even create like a different version of these post albums, like post albums, one single comment, where you are just going to use the first comment all the time, you know? I mean, this is a very silly example, but you can see that you can define a lot of different tasks for Locust to use and to execute against your application. But yeah, in this case, we are going to focus just on this one, the post albums task. So the first thing that it's going to do is to select a random comment from the list of comments that we imported from the example comments JSON. And after that, it's going to send this comment to the endpoint, to the predict sentiment endpoint. And that's basically it. All right, so now let's start the Locust dashboard and see how Locust is able to simulate different virtual users that are going to request our application. So for that, let's create another terminal and let's get back to our repo. And here you just need to run this Locust. Of course, if you go to the Locust web page, you will see in the documentation a lot of different arguments that you can pass to the Locust command. But in this case, I'm just going to pass this just a name, because everything is well defined inside the Locust file, inside the file that we have just seen. All right, so let's run Locust, and now a new application is running on your local host. So if you open this application, let's copy the URL. The port is 8089. Remember that our FastAPI application was running on 8000, but in this case it's 8089. If we get into this URL, you will see this beautiful Locust dashboard where you can define a set of parameters. So first of all, the number of users at peak concurrency. So Locust is going to increase at a certain pace from 0 users to this number of users at peak concurrency. Let's put, for example, 50 users at peak concurrency. It means that there are going to be 50 users sending requests to your application at the same time. Okay, then this ramp up is the number of users that are going to be started every second. So in this case, let's put 3, for example. So every second, 3 new simulated users are going to be created. And the host in this case is really silly because we are running against our local host. But in your case, you should put just the URL of your application. And yeah, and I think we can simply start. So if we click the start button, you will see a lot of different tabs that you can click. Generally, I like this one in here, this charts one that has 3 graphs. Of course, I think you can add more graphs, but I'm not really sure. And the first graph contains the total requests per second, the RPS. Since we are increasing the number of users, right now we have reached the peak concurrency, by the way, of 50 users, but you can see that the data requests per second is going to be increasing and increasing at the same rate as the number of users. And then this is the tricky one, the response times millisecond. Basically calculates some statistics about the response times in milliseconds. In this case, don't pay too much attention into the specific times because this is not a well optimized application. It's a really silly application. I mean, you wouldn't want an application which has a median of 1.7 seconds. Like, this would be a very, very bad sign for your application. And you can see that it started really well, like 100 milliseconds, things like that. But as time goes by and as the number of users using your applications concurrently increases, the response times are degrading a lot. So right now, yeah, like 1.5 seconds, 1.8 seconds, even 2 seconds, which is a lot. So this will be like a very red flag that you shouldn't deploy this application into production. That will be crazy. You will receive a lot of hate and a lot of bad reviews. So yeah, this is basically what I wanted to show you today. This is a short video. But yeah, I've been using Locust lately and I find it really, really useful. So I wanted to share this with you. So yeah, let me know in the comments what you think about Locust or if you have any other preferred frameworks for this. And click the like button if you like this content and also subscribe to the channel because it really helps me. And I think that's everything. So I'll see you in the next video.